In this quick video, we'll be talking about mid-segments of a triangle. So when we start off with a triangle like this, usually what you'll have to know is that the point at W, so right there, and the point at Y has perfectly bisected Z and X. In other words, ZY and YZ are congruent, and XW and WV are congruent. Once we know that, we can connect the dots from YW, and it turns out that this length right here, if I multiply it times 2, I get this length from Z to V. Okay, so in other words, let's delete some of this stuff. Let's say that I have, let's say that this length YW is 4. Then we know automatically that the length ZV is going to be 8, because there's a 2-to-1 ratio for both of these. Okay, so something that you may see in IXL could be, let's say, length ZV is 3x plus 2, and length YZ is 2x. And then we need to figure out, they'll say, well, what, solve for x, right? So what we can do is we can say that since it takes 2 YWs to equal ZV, I can say 2 times 2x, because that's 2 of this length right here, equals 3x plus 2. Okay, and then what we can do is we can distribute 2 into the inside of the parentheses, and we can say 4x equals 3x plus 2. And remember, our goal is to try and solve for x. That's over here. So what I'm going to do is I'm going to get all the variables on the left and all the numbers on the right. That means that I need to get this 3x over there. So I'm going to say minus 3x, and I'm left with x equals 2. Bam, just like that, x equals 2. And the cool thing is we can go back in and check too. We could say, well, if I put in 2 there, I get 4, 2 times 2. And if I put in 2 here, I get 3 times 2, which is 6, plus 2 equals 8. And these two check out, right? Because this should be exactly half of 8, or 2 4s equal 8.